Hello. Now in this topic we will see the derivatives, points of inflection, and maximum and minimum. It's a very nice exercise because it has all these characteristics, all these questions that we can answer. Now let's see what it says. Let fx be this function. Part of the graph of f is shown below. The graph of f has a local maximum at A and a local minimum at B, and the point of inflection at C. Now, what you must immediately think when you see this kind of questions. Since I have a local maximum or a local minimum, I understand for sure that the derivative of the function at some point there at A, it should be 0. Why? Because the first derivative, because it means that the tangent to that point is parallel to the x-axis, and always the derivative of a function is the gradient of the tangent. So here and here I know that the tangent is parallel to x, so the first derivative, it should be 0. On the other side, the inflection, when I have inflection points, it means so as to find them, what I have to do, I have to find where the second derivative is 0. That point is where I have an inflection point. So always when you see these keywords, you have to have in mind these simple things. Now let's see. Question A. Find the derivative of the first derivative of fx. Now A. So the first derivative will be 3x squared plus 6x minus 9. Now B. No, A2, basically this is I to I. So the second derivative is going to be 6x plus 6. So now I'm going to the question B. Find the x coordinate of the point of inflection at C. So as I said before, find the x coordinate. So basically find this point, which is C point. So how I can find it? Since it's an inflection point, I just need to take the second derivative and say that it's 0 and find that value of x. So 6x plus 6 is 0, so x is minus 1. So for sure the point here is when x is minus 1. That's where I have my inflection. Now I cannot find which is that point here, my y coordinate, because I don't have k. Next question, C. Now C says, given that the f of minus 1, so you see now they give me that point, f minus 1 is 14. So this value is 14. So now I can find how much is k. But let's see what the question says. Find how much is f of 0. Now if you will put f of x, if you put x 0, you will see it is 0, 0, 0, k. So how much is this k? No problem. Since I have a point, minus 1, 14, I can go find my point here. So 14 should be equal, I substitute the point into my function. 14 is equal minus 1 to the power of 3 plus 3 times minus 1 to the power of 2 minus 9 times minus 1 plus k. So 14 is equal minus 1 plus 3 plus 9 plus k, where from here I have 11, so k is 3. So I found my function that which is fx equals x cubed plus 3x squared minus 9x plus 3. This is my function. So how much is f of 0 is 3, the y-intercept. Hence, find the coordinates of the local maximum A. Now, where is the local maximum? The local or the maximums or minimums of the function. Now, the local maximum or minimum is where the first derivative is 0, which means 3x squared minus, sorry, let me see all the function, minus, sorry, plus 6x minus 9, plus 6x minus 9 is 0. So basically, if I divide by 3, it's x squared plus 2x minus 3 is 0. Sorry. So now I can do it by using Vieta formula. So it will be two numbers that they give me if I multiply them minus 3, and if I add them plus 2. So these numbers are plus 3 and minus 1. So from here I have that x equals minus 3 or x equals 1. Now here from the graph, if you see, obviously the point where x is minus 3 is the maximum. But how I can show it mathematically? It's easy. If I'll go, the other method is to go to my second derivative, which is this one, and put the value of x. If I'll put the value of x of minus 3, how much it will give me? Minus 18 plus 6, which is minus 12, which it means that the graph concaves down. So this is a maximum. Again, I can use the graph and say from the graph I see that local maximum is in minus 3.